Okay, first, set 5 question 1. Okay, they ask us the number 0.363636 with infinite decimal can be viewed as the infinite series 36 over 100 plus 36 over 10,000 plus 36 over million with sum s. Okay, now they ask us to list the terms of the partial sums S1, S2 and S3 and generalize the result to get the terms of Sn. Okay, now what should we do with this question? Okay, first of all, we need to find A. We need to find A. What is A actually? Okay, from this we can get A. We can get the answer for A. Okay, so A is we take it from the first infinite series. Okay, 36 over 100, right? Okay, is equal to 0.36. So this is equal to E. Okay, can you understand it? Okay, and then for the second one, we need to find the R. So R is equal to 0.01. Okay, now you know about that. Okay, next, what should we do now is we need to find S1. So S1, if you want to find S1, okay, we take it from the first this. Okay, 36 over 100. But we need to list it. So S1 is equal to 36 over 100 is equal to 0.36. Okay, same answer, right? Okay, next, they ask us to find S2. S2. How to find S2? This is S1. This is S2. So we need to plus it. Okay, now S2. How to get S2 is equal to 36 over 100 plus 36 over 10,000. So we will get the answer for 0.3636. Okay, remember that the number is 0.3636, right? So this is for first S1, this is for S2, this is for S3. So now S3, we will get this answer back. This answer, right? Okay. For S3, we need to plus it all. Okay. We need to add it all. Okay. Now S3 is equal to 36 over 100 plus 36 over 10,000 plus 36 over million is equal to 0.363636. We get the answer back, right? Okay. Now the problem is we need to find Sn. How to find Sn? Now, how to find Sn? We should use the formula. Okay, the formula of Sn. So the formula of Sn is this. Okay, this is the formula of Sn. Sn is equal to A multiplied by 1 minus R power of n over 1 minus R. Can you get it? Okay. Before this, I asked you to find A, right? We already got the answer for A, which is A is equal to 0.36, right? And then R is equal to 0.01. Okay, now, what should we do? We need to sub the answer of A and R into the formula of Sn. So now, we need to sub it into the formula. So now we already get the answer for Sn. Okay, Sn is equal to 0.36, okay, for A. And then multiply by 1 minus 0.01 power of n, okay, over 1 minus 0.01. So after we add it all, we already multiply it. Okay, we will get the answer for Sn. Sn is equal to 4 over 11 multiplied by 1 minus 1 over 100 power of n. So the answer of Sn is this. Okay. Okay, now for question number 2, they ask us to show that Sn minus 1 over 100 Sn equal to 36 over 100 multiplied by 1 minus 1 over 100 power of n. So hence, show that Sn can be represented as Sn equal to 4 over 11 multiplied by 1 minus 1 over 100n. So what should we do now is we need to sub the answer of Sn that we got just now from the question of A1. So we need to sub the answer, okay? Okay, before this, we already got the answer for Sn. So now we need to sub this answer, okay? This is equal to Sn, right? Okay, we need to sub this answer into this and this. Okay, we need to sub into. So now if we sub it, we will get 4 over 11 multiplied by 1 minus 1 over 100 power of n. Okay, minus 1 over 100 multiplied by 4 over 11 multiply 1 minus 1 over 100 power of n. So we already sub it, right? You notice that this is the answer from Sn, right? This only. Okay, can you get it? Okay, then if we already calculate it, we will get the answer for Sn for the question. So okay, if we already calculate it, we will get this answer, right? So if we get the answer, it means we already know that the answer is equal to 36 over 100 multiplied by 1 minus 1 over 100n power of n. So the question is we need to show that it is the same, right? This is equal. So we already shown it. Okay. Okay, for the next question, they ask us hence. Okay, they ask us again hence. Show that Sn can be represented as Sn equal to 4 over 11 multiplied by 1 minus 1 over 100 and power of n. Okay. Okay, now what should we do is we take it back this. Okay, this question we need to show that Sn is equal to 4 over 11 multiplied by 1 minus 1 over 100 and okay, now we write it back for this question. We write it back this given. Okay, Sn minus 1 over 100. Sn is equal to 36 over 100. Okay, multiplied by 1 minus 1 over 100 n. Okay, get it? Okay, then what should we do with this? Yeah, we can do it like this. We need to get Sn out. Okay, then we get this answer 1 over 100. Okay, same, right? Same with this, right? Okay, now what should we do? Okay, we minus it. This answer, this question, we minus it. 1 minus 1 over 100. Okay, we will get 0.99 Sn because we multiply it by Sn, right? You should remember it. Okay, then what should we do? We need to divide 0.99 into this. Okay, we need Sn. We need to show that Sn is equal to 4 over 11 multiply 1 minus 1 over 100 n. Okay, if we get this answer, which means we already get to show that Sn is equal to 4 over 11 multiplied by 1 minus 1 over 100 and okay, this settle. Okay, now we go to the question number A3. Okay, now they ask us based on the result from part 2. Okay, find the sum S of the series in form of rational number. Okay, okay, what should we do now is we need to find the sum, right? Okay, we use the formula. Okay, the formula of S infinity. Okay, the formula of this. Okay, we use it, right, to find the sum of the series in form of rational number. So S infinity is equal to A over 1 minus R. Okay, before this we already get the answer for A, right? What is it? A is equal to 0.36, right? Okay, and R is equal to 0.01. Okay, here. Okay, now we just need to sub it into the formula, so we will get the answer for sum of the series form of rational number. So we sub into this. So A is equal to 0.36. So 0.36 over 1 minus R is equal to 0.01. We will get the answer for the sums. Okay, the sum of the series in form of rational numbers. So we got 4 over 11. Okay, next for the questions 1B. Okay, 1AB. 1B. Verify the convergence of the series. Okay, when 7 over 10 power of n minus 1 from n equal to 2 until infinity and find its sum. Okay, now what should we do with this question? Is we need to make sure that 7 is getting out. Okay, now we got 7. Okay, n equal to 2 until infinity, 1 over 10 and minus 1. Now we already know that 7 is out. 7 we out it. Okay, then we got 7 limit n to infinity, 1 over 10 power of n minus 1 plus 1. Okay, over 1 over 10 power of n minus 1. So what should we do after this? 7 limit n to the power to infinity, 1 over 10 and 10 power of n multiplied by 10 power of n minus 1 over 1. Okay, we make it like this. Okay, then after we total up, okay, we got 7 limit n to infinity, 10 power n minus 1 over 10 power of n. Okay, then after that we got 7 limit n to infinity, 10 power of n multiplied by 10 minus 10 power of negative 1 over 10 power of n. So next 7 limit n infinity, 1 over 10. Alright, we cut it off. Okay, so just leave this 10 minus negative power of negative 1. So we get 1 over 10 if we check. Okay, and then now we get that 7 over 10 is less than 1. So that means it is convergence. That's it.
So the equation 2a is find the interval of convergence for the power series x power n over 3n n plus 1. So what we need to do, the first step is we need to do a formula. So what the formula? So formula is lim n to infinity modulus un plus 1 divided by un less than 1. So in the formula, what we can see, we have un plus 1 and un. So we got the two part, which is un plus 1 and un. So we got like this, okay, which is un plus 1 equal to x power n plus 1 over 3 power of n plus 1 n plus 2. Next, un equal to x power n over 3 power of n plus 1. So what we need to do, just follow the formula. Okay, just follow the formula, un plus 1 over un. So we got this. Okay, so we get this one. This, okay, un plus 1 divide by un. So if we divide, we just change the operation to be a multiple, and we need to change the place xn to be the, change the denominator, and xn to be a down like this, and 3 power of n the up like this. Okay, so what we need to do, the next step is we need to divide the two part, xn multiple and x power 1. This one is 3n multiple 3 power of 1 n plus 2 divide, multiple 3 power of n plus 1 over x power of n. So we just cross, just cancel x power n. Okay, so we got this one, lim n to infinity modulus x divide by 3 n plus 2 multiple n plus 1. So we just make it like this, modulus, and then the next is we just solve, we got the 0. So if 0 r equal to infinity, interval of convergence is a negative infinity to infinity. So the next is we need to express the 1 over 1 plus x3 x power 3 as a binomial series up to the term x power of 6. So we need to multiply by 1 over 1 plus x3 power of 1 over 2. We got 1 plus x power of 3 power of a negative 1 over 2. So what we need to do, okay, alright, so the equation, we got 1 plus x power of k, we got 1 plus k, alright, of 1 over to 1 factorial plus k minus 2 divided by 2 factorial x power 2 plus k column k minus 1 column k minus 2 x power 3 divided by 3 factorial and plus dot 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 dot. Okay, same like 1 plus x power of 3 column negative 1 over 2, we got this one, and final answer is 1 over 1 divided by 2, 1 minus 1 divided by 2 x power of 3 plus 3 divided 8 x power of c. So hence approximate limit 0 0.3 to 0. So we got this one. Okay, itu integrate the limit of 0 to 0.3. Okay, so this one we got 1 minus 1 over 2 x power 3 plus 3 over 8 x power 6, right? So we just replace and integral like always. Okay, what we got, and then we got okay, we got 1 divided by 8 multiple 3 divided by 56 Okay. Column x minus x power 4 plus x power 7. The limit is 0 and 0 x to, sorry, the limit is 0 to 0 0.3. Then we need to minus. So we just replace x to 0 0.3 minus 0. Okay. And the last we got 0 0.001956. So the question 2c, we need to consider the function f(x) equal to e power x. Okay. So for the one, find the Maclaurin series for f(x) and determine its interval of convergence. So we need to differentiate f(x). We got this one. Okay. We got the f for x, and we need to replace x to 0. We got f for 0. So the next, so is f(x), we got f0 plus f differentiate 0x plus 2 double differentiate 0x power of 2 over 2 factorial plus f triple differentiate 0x power of 2 divided by 3 factorial plus 5 differentiate 0x power of 4 divided by 4 factorial plus dot dot dot. And the final we got e power of x is 1 plus x power of 2 over 2 factorial plus 3 power of 3 minus 3 factorial. Divide by 3 factorial plus x power 4 divided by 4 factorial plus dot dot dot. We got the final answer. We got this one. So the series of x n over n factorial is a Maclaurin series. So for the theorem, the interval of convergence is negative infinity to infinity. So the equation 2 Roman. The 2 Roman. So the equation 2c 2 Roman. From 1 Roman, derive the series for the function gx cos x. So gx cos x equal to cos x. So we got exponent power of x plus exponent power of negative x divided by 2. So from 1 Roman, okay, we got this one, right? So we change the cos x. So we got 1 plus x power 2 divide 2 factorial plus x power 3 divide 3 factorial plus x power 4 divide 4 factorial plus plus, okay, 1 minus negative x plus negative x power 2 divide 2 factorial plus negative x power of 3 divide 3 factorial plus negative x power 4 divide 4 factorial and plus dot dot dot. And then we can cancel, and then the last one we got the 2 plus x2 plus 2. Then we got the 2 plus x power 2 plus x power 4 divided by 12 and divide by 2 because what? Because just follow the operation list. We need to divide 2, so the final answer divide by 2. Okay. So the next is 3 Roman, which is hence use the first 3 term to approximate the value of cos 0.5. Round your answer for decimal place. So cos x, you get this one, right? The answer. Just change x to 0.5. We got 1.1276 because we need to for decimal place. Okay.
For question 3a, the equation is given z equals to xy plus f in bracket x squared plus y squared. So we need to find y dz over dx minus v x dz over dy equals to y squared minus x squared. We can let e equals to x squared plus y squared and differentiate z at here. We will get dz over dx equals to y plus dz over dp times with dp over dx. So dp over dx, we will get 2x by using here. And to find dz over dp, we need to use dz over dy equals to x plus dz over dp times with dp over dy. So we can we can get dp over dy is 2y, and move x and 2y to the left side, we will get dz over dp equals to dz over dy minus x over 2y. And substitute in the equation, we will get dz over dx equals to y plus in bracket dz over dy minus x over 2y times with 2x in bracket y. We can cancel out 2y with 2 and y, and we get y dz over dx equals to y squared plus x in bracket dz over dy minus x, and we can multiply x in the bracket. We will get x dz over dy minus x squared. We can move x dz over dy to the left side, and we will get the answer y dz over dx minus x dz over dy equals to y squared minus x squared. Question 3b. Given the equation if fxy is equals to x to the power of 4 plus 4x squared y squared minus with 2x squared plus 2y squared minus 1. So the question wants we to find the critical point, saddle point, minimum point, or maximum point. So first we need to find the critical point. To find the critical point, we need to find fx, fy, fxx, fyy, and fxy. So our fx is 4x to the power of 3 plus 8xy squared minus 4x. And for fy, we get 8x squared y plus 4y. For fxx, we get 12x squared plus 8y squared minus 4. Fyy, we get 8x squared plus 4. And lastly, fxy, we get 16xy. To find the critical point, we need to use fx and fy and equals them to 0. 4x to the power of 3 plus 8xy squared minus 4x is equal to 0 is the first equation, and 8x squared y plus 4y equals to 0 is the second. And by using second, we can get the value of y is equals to 0, and we can substitute into the first equation, and we will get x is equals to 0, 1 and negative 1. So our critical point will be 0, 0, 1, 0, negative 1, 0. And to define the saddle point minimum or maximum, we need to use the formula fxx times with fyy minus with fxy squared. So for g00, we will get the answer negative 16, which is less than 0. So using by the formula, if it less than 0, it will become the saddle point. And for g10, we will get 96, which is greater than 0. And we need to substitute the value of xy, which is 10, into fxx, and we will get 8, which is greater than 0. And it means it will become the relative minimum. Same like for g negative 10, we will get the same answer, which is relative minimum. For question 3c, given the equation, double integral sine x squared plus y squared dA. And the equation for the graph is x squared plus y squared equals to 8 and y equals to 3x. And by sketching it, we get the graph like this. And next is we need to determine the value for the integral. As you can see, we use the y equals to 3x. We can substitute the value of y to r sin theta and x r cos theta. We will get theta will be equals to pi over 3. So we will get the point of the integral 0 to pi over 3, 0 to sec8 sine x squared plus y squared dA. To that, we can substitute the value of x squared plus y squared into r squared. like here, and put it into the formula, we will get 0 pi over 3 0 8 sine r square r dr d theta. And next we can let u equals to r square, and we will get du over 2 equals to r dr. So we can substitute here and transfer 1 over 2 at the front in front of the equation and integrate the equation, and we will get the answer 0.62809.
For question number 4a, we should find the value of integrate of this, which is z e over to y over y square with respect to dz dy dx, with the limit x, y, and 0 for the dz, ln 2 and 0 for the dy, and 1, 0 for the dx. Now integrate this equation with respect to dz, and we get z square e power of y and over 2y square. And we integrate until we get the value x cubed over 6, and we use the limits of the dx, and we get 1 over 6. For b, we have to find the value bounded region that bounded with xy plane, which is y axis, and xy plane, which is z axis, xz plane, y axis, yz plane, which is x axis, and x plus y plus z equal to 1, which is this line. So this is the question give y, the equation that we must integrate. So integrate with the limit 1 minus x minus y and 0 for dz, 1 0 1 0 for dy and dx. So integrate like always we did, and we get the final is 1 over x over 6 minus x squared over 4 for the last integrate after we integrate respect to dx, and we must add this value into the equation, and we get negative 1 over 12. For C, we have to find the value for the bounded region that bounded with y equal to 0, y equal to 1, z equal to 1, and z equal to x squared. The bounded region is here in the middle of all the equation, and we must integrate. There is no equation, which is we can assume there is 1, and the limit for dz is 1, x squared, for dy is 2, negative 2, and dx is 1, 0. First, we integrate respect to dz. When we integrate respect to dz, we get z. So we use the value, and we get 1 over x2, and we must integrate respect to dy, and we get y minus x squared y. And then we add the value into the equation, and we integrate respect to dx, we get 4x minus 4x cubed over 3, and we add the value into the equation, and we get 8 over 3. This is the volume or value for the bounded region. Question number 5, we must evaluate x, y over x squared plus y squared by using cylindrical coordinate. The limits for dz divided dx is 3 minus x squared minus y squared 0. Third, 1 minus x squared 0, 1, 0. When we use cylindrical coordinate, we must change the equation. For x, we change to r cos theta. For y, we change to r sin theta. And for x squared plus y squared, we change to r squared. For the dz dy dx, we change to r dz dr d theta. And the limit we also change. First, 3 minus x squared minus y squared, we change to 3 minus r squared. For third 1 equal to x squared, we change to 1, and the 1 we change to pi over 2. First, we can cancel the r, which 2r we can cancel from above and the bottom, and we get r cos theta sin theta. Then we integrate respect to dz and we get z r cos theta sin theta, and we use the value and we get in the bracket 3 minus r square r cos theta sin theta. Then we integrate with respect to dr and we get 3r square cos theta sin theta over 2 minus r power of 4 cos theta sin theta over 4. And then we use the value which is 1 and 0 for the limits dr, and then we integrate with respect to d theta and we get 5 over x sine 2 theta, and then we let u equal to 2 theta and d theta we get du over 2, and we change the d theta to du over 2, and the sine 2 theta we change to u and we get sine u 5 over x. We can move to the outside of the integration and we get negative cos u with the limits pi over 2 and 0, and then we change the u to 2 theta and we use the value and we get negative cos 2 in the bracket pi over 2 plus cos 2 in the bracket 0, and then we multiply by the 5 over 16 and we get 5 over 8. For the equation, this evaluate by using cylindrical coordinate.
We explain about question 5b. First, we need to sketch the graph by using the equation x squared plus y squared plus z squared equals to 4 and z equals to third x squared plus y squared. So our first equation is we need to find the mass of the solid. To find the mass, we can use the formula limit 0 to 2 pi, 0 to pi over 4, 0 to 2 third rho square times with rho square times sin phi d rho d phi d theta. So first, we need to integrate with respect to rho. 0 to 2 rho to the power of 3 sin phi d rho, and we get the answer 4 sin phi. Next, we need to solve for integrate phi by using limit 0 to pi over 4 sin phi d phi, and we get the answer 1.1716. And last, we need to integrate with respect to theta by using 0 to 2 pi 1716 d theta, and we get the answer 2.3432 pi. For the next question, we need to find the coordinate z by using formula msy over m. So first we need to find the msy by using the formula 0 to 2 pi, 0 to pi over 4, 0 to 2 rho to the power of 3 cos phi sin phi d rho d phi d theta. We can substitute cos phi sin phi into another form by using the formula 2 sin phi cos phi equal to sin 2 theta. We move 2 to the right side and we will get sin phi cos phi equals to 1 over 2 sin 2 phi. And we substitute into the equation and we will get the answer 2 sin 2 phi. Next, we need to find the integrate with respect to phi by using 0 to pi over 4 2 sin 2 phi d phi. We can let u equals to 2 phi and we will get du over 2 equals to d phi. We can substitute the value. We will get 0 to pi over 4 sin u du over 2. And we solve the equation and we will get the answer 1. Next, integrate with respect to theta by using 0 to 2 pi 1 d theta, and we will get the answer 2 pi. So our MSY will be equals to 2 pi. To get Z, we can use the formula MSY over M. Our M is 2.3432 pi. Solve the equation and we will get the answer 0.8535. For the last part, we need to state the center of the mass. From the graph, we can conclude that our x and y is equal to 0, and our z is equal to 0.8535. So the answer will be 0.8535.